All right, so we've discussed finding the determinant for a 2 by 2 matrix. Pretty simple. When it comes to 3 by 3s, it's a little bit more work. So for your basic 3 by 3 matrix, this is what your determinant is going to be. So it's going to be taking A11, or the entry in the first row, first column, times the determinant of A22, A23, A32, and A33. Now the way that we are forming that is by looking at this A11, and we're going to strike out those guys right there. And the little 2 by 2 that's left over is going to be the one that you see right next to the A11. And then we say minus A12 times the determinant. So here's A12. We're going to cross out all this other stuff, and the 4 terms that are left over will form the entries in this 2 by 2 matrix for which we'll find the determinant. And then we'll do plus A13 times the determinant. So here's A13. If we strike out everything else that's in those rows and the columns connected to that, then you're left with A21, A22, A31, and A32. So to find the determinant for a 3 by 3, you've got to find determinants for these 3 2 by 2s and multiply them times the corresponding entry. Now, these guys right here, so these little 2 by 2s, these guys are called minors. So these are minors of the larger matrix. Okay, so we have a certain way of referring to them. So this one right here would be minor 1, 1, because it's the 2 by 2 matrix that's formed from using entry A11. And of course, this guy would be minor 1, 2, and this guy would be minor 1, 3. So to form these minors, like you saw me do before, is that we remove all of the other entries in that. So I guess if you look at it like this, so M, I, J, you remove all of the entries that are in row I and column J, and then you write what's left over, and that forms your minor. So for example, if we have this, here is a matrix, here's a determinant, and we want to find M12 and M31. All right, so if I want to do M12, it's going to be the 2 by 2 matrix that's formed from, all right, so let's see, 1, 2 is going to be this guy right here. So if I strike out everything in that row and everything that's in that column, what's left over will be 0, -7, 8, and 2. So that's going to be the minor. And then we just need to do the arithmetic here. So as I do that product, I get 2 minus this other product, so that's minus 56, so minus a minus makes that plus. Why did I say 0 times 2 is 2? You guys have got to stop me before I get there, right? 0 times 2 is 0. And then we have minus, but that becomes plus 56. So minor 1, 2 is equal to 56. All right, so to find minor 3, 1, there we go. We want to look at finding the term 3, 1. So entry 3, 1 is this guy right here. So I'm going to strike out everything in that row. I'm going to strike out everything in that column. Then what's left over is what will populate the 2 by 2 matrix here. So we have -6, 2, 3, and -7. All right, so to find the determinant, -6 times -7 is equal to positive 42 minus the other product here, which is 6. So 42 minus 6 is 36. So these are the minors. Now, we also want to talk about cofactors. Okay, so we can talk about a cofactor A with a subscript I and J. And so this guy is just going to be -1 raised to the I plus j power times the minor of m ij. So if we go back to the previous page, what we have here, finding the determinant, there's a process for finding this, and you can say, oh, I've got to memorize this. That's a whole lot of stuff. But you'll notice there's a little pattern with the signs. So you have a positive for the first one, then a negative, and then a positive. But if we look at what we said here about the cofactor, right? So if I'm looking at the cofactor for entry 1, 1, that's going to be -1 times 1 plus 1, or 1 raised to the 1 plus 1 power, and then times the minor 1, 1. But that's just going to give you a positive 1, so it's just going to be that minor. However, when I look at the cofactor for the entry that's in row 1, column 2, that's -1 raised to the 1 plus 2 power times that minor. And because you have -1 to an odd power, you end up with a negative times that minor. So going back here to this previous page, you have here that 1 plus 2 is 3, so -1 to the third power gives you the negative. Here's 1 and 3, so 1 plus 3 is 4. -1 to the fourth power is equal to 1. So that's why you have a positive there. So the whole thing here about finding a determinant for any matrix, whether it's a 2 by 2, 3 by 3, the bigger they are, it all comes down to taking a single row or a single column, and you're going to take each entry and multiply it times its cofactor. So we could easily rewrite this determinant here. Suppose we were to focus on, let's do this. If I were to focus on this column right here. So I could take A12 times that cofactor, add to that A22 times that cofactor, and then A23 times that cofactor. And if you were to work this out, because we have here 1 plus 2 is 3, that would give us a negative times the minor. So that's kind of working out that cofactor. Because you have 2 plus 2 is even, it's just going to be a positive. So it's going to stay as A22 times whatever the minor is from that. And then you've got 2 plus 3, which is 5. -1 to the fifth power is -1. So this guy becomes a negative. And you would do it times that particular minor. So I could rewrite the minors here, just kind of seeing what would happen if I were to eliminate. So for this first term, if I were to eliminate everything in row 1 and column 2, then the 2 by 2 matrix that's left over, that's how I would form that. And so you see that there are multiple ways of working it out. So let's, so let's take a look at this guy, finding the determinant. So if I go through the process that we were talking about, you could pick any row and any column, and the answer is going to be the same. But typically what we do is that we focus on this first row. So, let's just use that guy. And so the way this is going to work is that we would take the first guy just the way we see it. And as we showed before, you kill the row and the column that's connected to, and you write what's left over. So it would make this -2, 6, -1, and -5 for that minor. Okay. Now, the next piece, because this would be, if you look at the coefficient here for this entry, this was 1, 1, which is why it didn't change the sign, it stayed negative. This is 1, 2, so it's odd, so it would change the sign and make this a minus. So minus 1 times the determinant formed by killing that row and killing that column. And so you see you'd have 3, 6, negative 7, and negative 5. For this last entry here, 1 and 3, so row 1, column 3, 1 plus 3 is 4. Negative 1, 2, and even power is going to be positive, so we keep the sign as it is. So we say plus 2 times the determinant of the 2 by 2 matrix formed by killing that row, killing that column. So we have 3, negative 2, negative 7, negative 1. So it is kind of a bit of a process to work this out. But here it's just a matter of doing some simple arithmetic. It shouldn't be all that bad. So let's just do parentheses here. When I go across this way, I get 10. Minus, and I go across this way, that's negative 6. So minus negative makes that plus 6. And then we have minus 1 times, we do the same thing. So this product is negative 15. Minus the other product, that's negative 42, so it makes that a plus 42. And then plus 2 times, this product is negative 3, minus the other product there is positive 14. So it stays minus 14. And then from here, we just keep working this out. Is this okay to show steps? So we have negative 4 times 16 minus 1 times 27 plus 2 times negative 17. This gives me negative 64 minus 27 minus 34. Yeah, I know I've got the calculator sitting there. I should probably just go there. But I feel like I can't do that. I just can't. So if I add this, that's going to give me 15, carry the 1. That's going to give me 12. Yeah, so we end up with a negative 125. That's the determinant. So let's just double check with the calculator. All right, so I need to first create my matrix. We have a 3 by 3. And let's just make sure that we have this typed in correctly. So we have negative 4, 1, 2, 3, negative 2, 6, negative 7, negative 1, negative 5. Let's make sure we have all that stuff copied correctly. Looks good. So let's quit. Go back to the matrix menu. First thing we want to do is the determinant. And go back here and grab matrix A and calculate negative 125. Boom. Now, there is another way to do this. So they don't talk about it in the textbook, but it's something that I remembered from a long, long time ago. So here's what we're going to do. We're going to take this matrix. I'm just going to, rewrite it if I've got room for it. Why don't you let me scroll down more? All right. So let's take the matrix just as we've seen before. So we have 3, negative 2, 6, negative 7, negative 1, and negative 5. All right. Here's the trick. Take these first 2 columns and rewrite them on the outside. Negative 4, 3, negative 7, 1, negative 2, and negative 1. So here's what we're going to do. We are going to take the product of this diagonal, and that diagonal. Okay. So when I do that, let's see, we've got negative 4 times 2 times negative 5. So that's negative 40. 1 times 6 times negative 7 is negative 42. 2 times 3 times negative 1 is negative 6. And this total is negative 88. And then we're going to do the diagonals going upwards. So we're going to take this diagonal, this one, and that one. And let's see, that's going to give us negative 7 times negative 2 times 2 is positive 28. Negative 1 times 6 times negative 4 is positive 24. Negative 5 times 3 times 1 is negative 15. And altogether, that's going to give us, let's see, that's going to be 37. I think that's right. Let me double check that. So it's going to be 40, 52. Yeah. So we have these two numbers, right? So we have the ones that were going down, and we have the ones that were going up. And so we're going to do it in this order. We take the ones going down, and we subtract the ones that we had going up. And you see that you still get negative 125, but a lot less work. So tell you what, let's see if we can apply that to this next one. So let's do the shortcut first, and I'm going to show you how to make good use of your minors and choosing the right row and right column. All right, so the shortcut would say copy these two pieces. So I'm going to copy over the 2, 4, negative 5, 3, 0, negative 3. So we're first going to calculate these diagonals. So 2 times, well, that's just going to be 0. 3 times 9 times negative 5. All right, so that's 45 times 3. That's going to be negative 135. Negative 6 times 4 times negative 3. So 24 times 3 is 72. It's going to be a positive 72. Then we do the diagonals going up. So this one, and that one. So 5, that's just going to give me 0. Negative 3 times 9 times 2 is negative 54. 2 times 4 times 3, 12 times 2, yeah, 24. And altogether we get negative 30. Well, I didn't do this down here. So negative 135 plus 72 is negative 63. Yeah, I gotta be really careful about just doing stuff in my head. I'm not so sure that that is working out nearly as nicely as it used to. All right, so then we finish this off by doing negative 63 minus negative 30. All right, so negative 63 plus 30 is equal to negative 33. That's the determinant for this matrix. All right, so what if we didn't do the shortcut? What if we still did the whole thing with the minors and all that? Well, you want to pick a row or a column, typically that has a 0. If you have more zeros, the more the merrier. So I say to either do this column or that row. It wouldn't really matter at the end. So let's just do the row 409. Keep in mind what these terms are. So this is the second row and the first column. So 2 plus 1 is 3. That's odd. So we're going to start off with doing the negative of that sign. So negative 4 times the determinant. As we've seen before, kill that row, kill that column, and you write what's left over. So it'd give me 3, negative 6, negative 3, 2. This next one is 2 and 2. That's 4. Negative 1 to the fourth is positive. So we keep the sign there. It doesn't really matter because it's 0 times the determinant. Again, I could put anything there. It doesn't matter because 0 times anything is 0. But we'd kill those guys right there, leaving us with 2, negative 6, negative 5, and 2. And then for this last one, entry of 2 and 3, second row, third column. 2 plus 3 is 5. Negative 1 to the fifth would be a negative, so it's going to be minus 9 times the determinant from destroying this row and that column. So that's 2, 3, negative 5, negative 3. And then we would just work this out. We should still get negative 33, but let's just confirm. All of this is just going to give me 0. So I don't need to worry about what is the determinant of that. This is 0. So I'm going to have negative 4 times, let's see, that guy's going to give me 6 minus this guy, so that's 18. Then we have minus 9 times, this diagonal is negative 6. This diagonal is minus 15, so it's going to be plus 15. All right, let's see what we get here. Negative 4 times negative 12 minus 9 times, that is positive 9. So we have 48 minus 81, and that equals negative 33. Hey, it's what we already had. How fantastic is that? All right. I think the really cool thing, though, is the trick that we see right here, how we can make finding the determinant of a 3 by 3 very, very simple, as long as we get these guys in the right order. We understand that what I have here in blue, that's going to be the first number. What I have here, the diagonal is going green, that's the second number that you end up subtracting. So in the next video, we're going to see how we use this to solve big 3 by 3 systems. So yeah, don't go away.